so when the testosterone is injected into the muscle, which can either be the glute, the thigh, sometimes if you've got big shoulders you can inject into the shoulder, it has to get from the muscle into the blood. And this is the rate limiting step because it diffuses slowly from the site of injection into the blood. Once the testosterone ester is in the blood, there is a rapid hydrolysis. What that means is the testosterone ester is broken down to the unesterified testosterone. If we look at what actually happens molecularly, so at the molecular level, so this is the chemical formula for testosterone decanoate. We know it's decanoate because we've got 10 carbon atoms in this ester side chain. An enzyme in the blood, an esterase enzyme in the blood, acts here to cleave this ester side chain. And remember, this hydrolysis in the blood is rapid, and then we get the testosterone hormone. So if you compare this molecular structure with this one, you can see the action occurs here to produce this hormone. Again, in the blood, this is rapid. From the site of injection to the blood, that's slow. And we can control the rate of this diffusion by altering the length of this side chain. Then this testosterone hormone is then free to act on the androgen receptor once this ester side chain has been cleaved. Once we have this free testosterone hormone in the blood, it's free to act on the androgen receptor. It can further go another modification by the enzyme 5-alpha reductase to produce dihydrotestosterone, or DHT, which is much more potent than testosterone, which can also act on the androgen receptor. Testosterone can also be modified by the aromatase enzyme, predominantly in the fat tissue, to produce estradiol, which can then act on the estrogen receptor. Estrogen is present in men, and it's important for our bone health and our mental health.